What we'll be starting now is really a very important aspect of how we go into space and how we are going to sustain our presence in space, continue to do a lot of our research. I think we've already seen the wonderful impact commercial has had on both flying our academic experiments as well as advancing really the development of space products in other different areas, as we've seen on the International Space Station. And I think as we begin to move out to cislunar and also lunar areas and beyond to Mars, the area of economic impacts and commercialization are also going to have a very important part and role in that process. And so what I'd like to do is, this session is developing a space economy. And we'll have presentations by Doug Comstock, Michael Roberts of the ISS National Lab, and Tom Stafford. And so with that, I'd like to introduce Doug Comstock. Thank you.
Thanks. It's a pleasure to be here with you all. Been here for a few days and enjoyed some good snowfall, as you'd expect in Denver. And appreciate everybody who's here on a Saturday, the diehards here in the audience, and appreciate your participation today. I wanted to share with you what NASA has planned for commercial development of low Earth orbit. And in the position I'm in, I'm working in the Human Exploration and Operations Mission Directorate at NASA headquarters to develop a plan for how we can partner with industry to develop the low Earth orbit economy. And we put forward that plan, and we're now beginning to execute against that plan. And I'll share with you sort of the overview of the plan and where we are in terms of our execution today. So if I push the green button, I'll just say next slide. So first I want to share the vision that NASA has for economic development in low Earth orbit. And you can think about this in sort of 3 time frames. Near-term activities where we've got the ISS and all the international partners that we have and all the ongoing research there through National Lab and through NASA for supporting the exploration objectives. And we want to make maximum use of the capabilities that we have on the ISS to begin to develop commercial markets. There are a lot of nascent markets that have potential, but a few that really have been demonstrated to the point that we need in the future to really be a part of this low Earth orbit economy. And in the midterm, we're going to partner with industry to develop commercial destinations in low Earth orbit. So you will start to see commercial destinations attached to the station or as free flyer. We'll start proving those out and beginning to do activities on those stations, and it'll be sort of a transition period between ISS and these new commercial destinations. And then in the long term, we'll have privately owned and operated destinations in low Earth orbit, and those will be the capabilities that NASA will purchase services from to do all the research and development and technology demonstration and astronaut training that NASA needs to do. And there will be a transition point where there won't be ISS anymore, but there will be just these commercial destinations where NASA will be one of many customers for those destinations. And you can sort of see the vehicles along the right-hand side there. Let's go to the next slide. And next slide. Try this again. Okay. So just to give a little context, this process is something that is really a multi-decade process, and we're still in the middle of it. And if you go back almost 2 decades ago, NASA started down this path with developing commercial capabilities in partnership with industry to develop cargo to the space station and crew to the space station. Started with cargo with the COTS, the Commercial Orbital Transportation Services, which was a partnership to develop the capabilities, and then followed up with commercial resupply services contracts to purchase those services from those capabilities that were developed under the partnership. So it's important to remember sort of the 2-step process in this: partner with industry to develop the capabilities, and then competitively acquire services from those capabilities. And NASA applied that same approach with developing commercial crew. And we'll hopefully have another orbital flight test next month and be delivering crew next year. It has followed that similar model where we partnered with Boeing and SpaceX to develop the capability, and then we've had firm fixed price contracts for the acquisition of those services. And the ISS has also evolved over this time period and been a key part of this evolution. The National Lab was designated by Congress in 2005, about the same time frame when we had some of the initial COTS competitions. And it's evolved over time, and now it's managed by the CASIS. And we have a number of commercial facilities that are on the station now. And so we're beginning to develop a real ecosystem there with commercially owned facilities and commercial activities that are using those facilities. And we've had instruments that have helped us along this way. There's a ISS NRA for utilization that's been a key mechanism, and I'll talk a little bit more about this, but the ISS is the centerpiece for this whole activity and is really going to help move the commercial markets along and transition in the future to these commercial destinations. So that sort of leads us to where we are now with the commercial LEO development. And we conducted about a dozen industry studies last year to get some perspectives from industry on what they saw as the future for commercial activities in low Earth orbit. And those studies were very helpful. They talked about what the potential markets are, what some of the concepts would be, and they helped inform the strategy that we developed that has 5 points that you can see summarized here. With the ISS commercial use and pricing policy, private astronaut missions, commercial destination development, stimulating demand, and then talking about what NASA's long-term demand forecast is as a customer. And let's go to the next slide, and I'll talk a little bit more about those 5 points. I guess. So we put together this plan, and you can see the URL there. It's all available on the website, nasa.gov/LEO economy. All this information's there. And we rolled this plan out in June of this year at NASDAQ on Wall Street. And part of the reason for that location was intentional. We wanted to reach a much broader audience than just the typical aerospace community. Because we really need that broader audience to participate in this economy as we're going forward, and that ended up, I think, being quite successful and created awareness of the opportunities and the plans that weren't really there before. So the 5 elements of the plan, and I'll talk a little bit more about each of these in the following slides, are the commercial use and pricing policy. So we established areas of commercial use that hadn't been permitted before. We didn't require any new legislative authority to do this. This was within NASA's existing authority, and the agency just sort of changed the policy so we would allow these sort of commercial activities on the ISS, recognizing how important they were to developing this commercial economy going forward. And we also had a pricing policy established that set prices for the services for transportation to and from and astronaut time and other things on the station. And we also set aside 5% of NASA's share of ISS resources to make available for these commercial activities. And I'll talk a little bit more about that. The second was enabling private astronauts to go to the station on private astronaut missions. So these would be commercially purchased missions with like four seats that would be sold to private individuals or other nations around the world who wanted to send astronauts to the station. And this would increase the number of flights going to the ISS beyond the commercial crew flights that NASA has already purchased from Boeing and SpaceX. And we could have as many as 2 flights per year that the station is ready to accommodate. And they're actually on the space station planning manifest now. And station, if the vehicle would be ready, could accommodate the first mission as early as October of next year. And then about every 6 months after that. And these could be missions for up to 30 days. The third area is this process for developing commercial low Earth orbit destinations in partnership with industry. And this is very similar to the same model that we used for commercial cargo and commercial crew, where we'll have acquisitions to partner with industry to develop the capability, and then have service acquisition contracts competitively awarded in the future from those as well. The fourth area is seeking out opportunities to stimulate scalable and sustainable demand in LEO. And this really builds on all the work that's gone on the station to date. There's been a lot of tremendous commercial work going through National Lab. In fact, over the last few years, more than half of the research projects going to the station through National Lab have been commercial R&D projects. One of the things that sort of connected with that is the new commercial use and pricing policy. Things going through the National Lab have to be R&D, and so that sort of limits the scope of activities that can go through National Lab. But at some point, commercial activity is going to move beyond R&D and actually go into commercial operations or actual commercial manufacturing in orbit. So with the new commercial use policy, we have a path where once they graduate from the R&D phase, they can do those things on the station, given the new commercial use and pricing policy. The fifth area is to quantify the agency's long-term needs for LEO. So this is sort of a demand forecast. There was a detailed white paper that was done a couple years ago that went into all the areas of demand that NASA would be interested in the future, many continuing the things that we're currently doing now on station. But we wanted to help reduce uncertainty for industry on what NASA would be as a customer in the future. So we wanted to quantify those, and we updated that white paper and quantified the demand forecast as part of the plan that was rolled out in June of this year. So those are the overview of the 5 areas. I want to talk a little bit about the commercial use and pricing policy and the commercial resource allocation. And this just sort of summarizes it's actually, I guess, previous rather than current. The current is the one on the right now. But, the U.S. Capabilities are essentially split 50-50 between ISS National Lab and NASA, with the balance of the U.S. segment going to the international partners. And with this new policy change, ISS National Lab still has 50% of the U.S. capacity, but of NASA's 50%, 5% of that now goes for commercial activities. So of the U.S. total, that represents about 2.5%, NASA 47.5%, and ISS National Lab still 50%. And with this policy, we're allowed to do things that we couldn't do before. There are certain things that NASA civil servant astronauts can do, and certain things that they aren't allowed to do just due to standard civil service restrictions and ethics rules and so on. And one example, and where things could be enabled by having private astronaut missions, and I'll talk about this more in a little bit, is we're allowing things like commercials to be filmed on the space station. So with NASA civil service astronauts, they can be behind the camera and say filming a commercial on the space station that could be used by some commercial company, but they couldn't appear in the commercial in any recognizable way. And NASA would need to be reimbursed by the company that was doing the commercial for the use of the astronaut time and the resources on board the station. But if a private astronaut was going there that didn't have the same sort of ethics constraints that civil servants do, then they could not only film the commercial, but they could appear in the commercial. So that's another aspect that sort of opens up some of the possibilities for this going forward. So some of the benefits of these private astronaut missions, like I talked about, and again, we are planning to accommodate as many as 2 per year, about 1 every 6 months, and these could be missions of up to 30 days. And this would allow industry to purchase these commercial missions, gain insight into the market from how they're able to sell the seats for these missions, and begin to establish business-to-business relationships for conducting these missions. So NASA would not be in the middle of these transactions. This would be a commercial to commercial transaction in terms of purchasing the flight. And It could be that Boeing or SpaceX would want to pursue a private astronaut mission and get customers to fill their seats. And there's also been other companies who would want to put together a mission and then purchase a flight from Boeing and SpaceX. And we have a new focus area, this focus area 3 under the ISS utilization NRA, that is targeted at these private astronaut missions to get ideas coming in for folks who may be interested in doing these missions. And we think by pursuing this path, it helps to reduce some of the market risk to the commercial LEO destination providers by beginning to show that there is a market for these private astronauts that would be going to their commercial destinations, and reduce the risk and the uncertainty for their business planning. And as I mentioned, it expands the types of commercial activities that you can do where you wouldn't be restricted by civil service constraints. And it also would increase the size of the market and the flight rate for these commercial crew launch service providers, and could also provide additional crew time. If folks that were going on these private astronaut missions were trained, they could support research activities and other R&D activities on the station. So next I'll talk a little bit more about our plan for developing these LEO destinations. And what we have here is a sort of notional roadmap that lays out the path, and you can see the cartoons on the top where, again, in the near term, we've got the ISS. In the midterm, we're going to have the ISS with commercial module attached and or free flyers. And then in the long term, we won't have ISS, but we'll have these commercial destinations in low Earth orbit. And we're pursuing a two-pronged approach to developing these capabilities with industry. One that would go through the ISS, so it initially would be attached to the Node 2 forward port on the ISS, and with a evolution path to becoming a free flyer destination at some point in the future. And we have issued that under the Next Step 2 broad agency announcement under Appendix I, and we have proposals in and are in the evaluation process for that right now. And the free flyer path is where they would just go directly to being a free flyer, and that's Appendix K under the Next Step 2 BAA. And we have the draft RFP out now. We have Industry Day a couple of weeks ago, and we are reviewing feedback from industry and working to get the final RFP out, and expect that may go out sometime next week, possibly. So we're working to get that finalized. And that'll have a 90-day turnaround on the proposals. So we'll expect proposals probably next March timeframe. So we're pursuing those two approaches. We have you see the red line there with our portfolio decision. So with the different concepts coming in, we're asking them, what do you need from NASA? There are certain elements that NASA may have on the ground, certain elements, could even be modules from the station or equipment from the station that they would want to transition to their commercial destination. So we're asking industry, what do you need? And we need to look across the portfolio of options where there may be limited resources for some of these things they're asking for. And if there are multiple concepts asking for the same thing, we need to make a decision on, if there's only one, which path are we going to go? And we also want to look across the capabilities, and we're not requiring that any one of the industry partners meet all of NASA's needs from our demand forecast, but we want to look across the portfolio to make sure that with the combination of destinations that we'll have, that we can meet all our needs. And it's sort of a similar approach again to what we did with commercial cargo, where there was a list of requirements, but no dictate that any provider would meet all of them. So, some of the providers provide return capability and some don't, as an example. And so we're pursuing these two paths, and then we'll also follow the approach that we did with cargo and crew, where we'll have service acquisition competitions on a competitive basis for what NASA needs in the future. And in terms of stimulating demand, this is where National Lab is going to continue to play a key role, partnering with industry. We've already begun to develop a real ecosystem on the station. Like I mentioned, we've got a lot of commercial hardware up there that's owned by commercial companies. See a number of facilities and companies summarized here. And there's a lot of commercial research already going on the station, and most of this is going through National Lab. So they've really built a great partnership with industry on advancing these R&D activities. And we want to continue to mature these till they get to the point where they're moving beyond R&D and actually creating businesses in low Earth orbit. And we want to pursue these opportunities through a number of funding opportunities. We've got Appendix J in the Next Steps to BAA, which is seeking to partner with industry for broad demand stimulation, which could get at things like reducing transportation costs, which is still one of the key constraints and really drives the business model for most of these concepts. And we're seeking to advance concepts in space manufacturing and biopharmaceuticals, et cetera. And in terms of NASA's future demand, these are the areas that were part of the forecast that was put out: human research, technology demos, crew accommodation and training, science, biological and physical research, and national lab services. So the work that all of you do in your community is definitely going to continue. It'll transition from ISS to these commercial destinations at some point in the future. And the intent is to continue national lab services as well into the future, purchasing the services from these commercial destinations to support those on-orbit research activities. So that's a summary in a nutshell. And like I mentioned, this is the website where you can learn more about the plan. And there's a lot of information there. So I'll turn it back over and look forward to your questions in a few minutes. Thank you.
Thank you, Doug. That was really, really inspiring. I'd like to now introduce Michael Roberts of the ISS National Lab.
Excuse me. Thank you, everyone. Good morning and welcome to Saturday morning. I'm glad to see dozens of you here. That's more than I actually expected might show up today. So my job this morning on this topic is to speak to you about the ISS National Lab perspective on developing a space economy. So I've, as a subtitle, added the view from the ISS cupola. I mention that because when we have a new vantage point, as we do from the International Space Station, there are facets of that work both from the viewpoint, the perspective of the viewer, as well as the vista that lies out there before them. So what we have learned over the past 8 years of our management of the International Space Station National Laboratory is that there are many perspectives that are brought to the International Space Station National Laboratory based solely upon the target objectives of those R&D activities. So I like to talk of the ISS National Laboratory as a non-denominational laboratory. We invite and work with not only those commercial entities that see the access to space as enabling their R&D activities and benefiting their research outcomes here on Earth. We also work very closely with other government agencies, and OGAs in this case refers to any agency plus NASA. So we've been very successful, and I think you've seen a lot of presentations at this conference outlining the success of those new government agencies, in some cases who had prior relationships with NASA, but are expanding those into the commercial realm and access to ISS National Lab in the future. I'm going to spend just a couple of slides going over things that I hope are familiar to you, but in some cases it's always good to go back to the touchstone of who we are. So the mission of the International Space Station National Laboratory, and we operate through a cooperative agreement with NASA, is to foster scientific discovery and technological innovation in space. Coupled with that is our mission to expand U.S. leadership in commercial space and inspire the next generation. Simply put, we are seeking those who want to take their R&D activities to space to benefit life on Earth. What we do in approaching that question to a community of new to space investigators, very commonly those that we interact with on a daily basis in the commercial sector, have not considered the space environment as a relative needed environment for their R&D activities. So we are the tip of the spear in describing to them why space is important to their particular portfolio. The way that we typically approach that is to discuss things which I think are first and foremost in the thoughts of any investigators, any hardware developers, engineers, and innovators in this audience. Microgravity, especially persistent exposure to microgravity, affects the fundamental physics, and that effect upon the fundamental physics has profound outcomes on living systems that are put into that environment. Most importantly, from our interaction with those who are new to space, is the understanding that those effects occur at multiple levels. So whether you're interested in nano or molecular scale effects, or you're interested in effects that occur in whole systems level, whether they're biological systems or engineered systems, there are particular niches within the International Space Station National Laboratory and that access to the persistent microgravity environment that can have profound impacts upon the type of R&D activities that you return. Just to touch again briefly on some of those effects and the message that we convey to those new to space. Microgravity removes gravity-dependent physical phenomena, including buoyancy-driven convection, density-driven segregation, and matter-container interaction. And in this case, consider that matter or materials includes biological living systems as well. Reduction in these phenomena directly affects heat and mass transport, interfacial dynamics, multi-phase system dynamics, solidification kinetics and thermodynamics, and fluid dynamics. And as a life scientist, I wanted to emphasize that all of these profound physical changes directly and indirectly impact living systems in those environments. How do we manage the space? So this is, I think, the one slide that Doug and I share in our presentations, which is a good thing. I've broken it out a little bit into showing that breakup in International Space Station resource allocation between NASA utilization and ISS US National Laboratory allocation includes a number of programs who have continuing interest and require access to the International Space Station for R&D development. And in many cases, that is also continuing to drive and catalyze commercial access to space, both on the supply side and the demand side. I wanted to spend a minute or so talking about the ISS National Lab as a catalyst. So what we have been successful in doing over the past 8 years, and then NASA had achieved success at this as well in the period from 2005 to 2011, when it was directly managing the International Space Station National Laboratory as a resource, was creating demand for access to space, for R&D activities that again translated to benefit here on Earth. NASA, as Doug highlighted, was very successful in building different contractual vehicles through formal procurement mechanisms as well as creative contractual constructs to enable commercial access to provide services for those seeking to access space. And also beginning the early stages of exploring interest in the investment community for funding R&D activities in that environment. What we've been able to do on the International Space Station National Laboratory since then is greatly expand those opportunities. So if I can go back to the pie chart here, what you're going to see over this midterm and long-term transition is this pie increase. So when Doug or I or others talk about increased access to space, or I will talk about in a few minutes, focus on particular program areas, keep in mind that the percentages may not change in the midterm, but the overall volume of activities in that environment will continue to grow because of the increase in supply and the increase in demand that we're seeing. So those commercial service providers are going to add to technology platforms ranging from individual pieces of hardware all the way through to new vehicles that interact with space station, or maybe free flyers that don't need to interact with the International Space Station. Since the inception of the ISS US National Lab in CASIS, we've seen 17 new commercial lab facilities come online. We've also been very successful, as I mentioned, in continuing to expand that universe of commercial implementation partners who are critical to translating R&D thoughts from a terrestrial perspective to the space dimension. And we're most proud of the continuing and increasing investment that we see not only from a member investor network of venture capitalists, but the direct partnerships we have with the National Institutes of Health and the National Science Foundation and elements of DoD. So part of our mission is also building the business case for space-based R&D. And we see the best pathway to doing that by having focused programs that include both basic and applied research and technology development activities with clear lines of sight to industrialization. So I wanted to spend a minute here talking about a distinction between commercialization and industrialization. So commercialization itself is certainly a necessary step towards continuous utilization and exploration of the space environment. But commercialization, although being necessary, is not by itself sufficient. So commercialization may be defined as the process of managing or running something principally for financial gain. So at the risk of sounding like Gordon Gekko from Wall Street a few years ago, who said, greed is good, commercialization is good, but it is not the end all be all. So at the same time that the International Space Station was beginning assembly in 1998 and 1999, there was a block store here on Earth called Blockbuster Video, and a show of hands for those who have ever used Blockbuster Video. All right, all hail to my fellow boomers out there. Blockbuster Video at the time in 1998 had over 9,000 stores in the United States. And they had essentially cornered the market on VCR rental capability. That big blocky thing over to the right, for those of you younger than a certain age, is a VCR tape. So Blockbuster Video was very successful in their commercialization effort, and they had what at the time was cutting edge technology for content distribution to a needy audience out there. And they saw an incremental increase in the quality of that technology with the transition from VCR tapes over to CD and DVDs. It wasn't enough to keep them in existence, though. From 1998 until now, they have fallen from 9,000 stores in the world to one. There's one Blockbuster left in the world. I'm told it still has its doors open in Bend, Oregon. I use this as an example because we don't want or see the International Space Station National Laboratory's future as becoming a block store. It's more important than that. And in order to prevent that thought process from permeating all those who utilize the International Space Station, we need to think about moving beyond simple commercialization to industrialization. Industrialization is important because not only does it advance our R&D interests, it also is transformative in the same way that science and technology development is transformative. The goal of industrialization has higher aims. And one definition of industrialization is written here, specifically describes that potential for transforming a human group in society. That's what we're seeking to do in our role at ISS National Lab as we continue into the future. So what we have within our grasp is the only national laboratory operating off Earth, off planet, and its launch, its access to everyone in this room and anyone in the United States is only a few hours away. So we see this ability to innovate at orbital velocity as being extremely important and critical, even to those R&D interests in the commercial sector and in other government agencies that have not been traditional users or have any interest in space as a laboratory environment for them. With that in mind, we have over the past year continued to shape our portfolio to focus on a couple of program areas where we see not only significant potential for growth in the near term on the International Space Station and those new commercial facilities coming online, but we see these as areas where there is substantial opportunities for investment from both the public and private sectors going forward. So again, these areas are not going to be developed to the exclusion of any idea that comes from any segment of the R&D interest in the United States, but these are designed to be areas where we can see the most significant return on investment in the short term. First area is in the area of advanced materials and manufacturing, projects that develop next generation production methods or improve our fundamental understanding of mechanisms involved in material transformations, again in the absence of gravity. Second is industrialized biomedicine. This focuses on projects that enable biomedical advancements with a defined pathway for translation. So again, we are open to any concept that comes in, whether it's on the fundamental or translational and clinical end of the pipeline. But we want those investigators or those institutions or those consortia of investigators to be thinking about the potential application and its Earth benefit as they come to utilize the resources on board the International Space Station National Laboratory. I wanted to quickly go through a few examples and one business case for each of these where we have already seen significant uptrends, positive indicators of interest from public and private sectors in these two topic areas. In advanced materials and manufacturing through fiscal year 2019, we've already seen 37 payloads flown. We have 31 active projects in the ISS National Lab portfolio that utilize the services of 11 commercial implementation partners. We've also seen our release of an advanced materials request for proposals in fiscal year 19, and a continuation of our partnership with the National Science Foundation, looking at the fundamental aspects of transport phenomena. This continues on a series of investigations sponsored by the National Science Foundation, which are specifically focused on fundamental aspects of fluid flow and combustion phenomena in the microgravity environment that inform the translational and more applied ends of advanced materials and manufacturing in the microgravity environment. One example that I think most in the audience will be familiar with began as a NASA-sponsored investigation by a NASA researcher who was interested in looking at the effects of microgravity on optical fiber pores. So there are currently 3 separate commercially funded investigations operating on board the International Space Station that are focused on the manufacture of Z-band optical fibers in that environment. So there is active competition ongoing in the space environment to define and optimize the process for manufacturing these optical fibers. All 3 of these companies have defined a business outcome where it is financially viable for them to take the raw materials into the space environment to manufacture the Z-band optical fibers and return them to Earth, even if they have to pay for the cost of launch services themselves. So the commercialization aspect of industrial access to the low Earth orbit as a research and development environment is real, and it's here now. In industrialized biomedicine, we've seen over $32 million in grant commitments from multi-year programs in partnership with both the National Science Foundation through tissue engineering applications, where NSF is interested in the intersection between biological systems inside of fluid flow paths, and investments from the National Institutes of Health, as you heard from Lucy Lowe yesterday. Over 20 publications have been generated from these investigations already. New facilities were launched in 2019, including a biofabrication facility for 3D bioprinting. And we're seeing continued interest, again, from the National Science Foundation in continuing funding mechanisms for fundamental investigations that look at that intersection between tissues, biological systems, and the microgravity environment. And again, each of these individual projects have translated into new business, new increases in supply side economics for implementation partners who develop, operate, and help the investigators design their experiments to operate in the microgravity environment. One case study that we've cited frequently, but I think is important to continue to highlight, is a project that's been developed by Merck. Merck scientist Paul Reichert has been a frequent flyer looking at the use of the microgravity environment for protein crystal growth experiments. Those experiments have returned very valuable information to Schering-Plough and now Merck scientists. But most recently, the focus has transitioned from drug discovery to actually thinking about new ways to formulate these drugs in the microgravity environment. And that's a very fundamental and profound shift, because that provides pharmaceutical companies the opportunity to not necessarily have to look at an investigational new drugs, but there are drugs that are already clinically validated in their portfolio that can be more efficacious and have fewer side effects if they can improve their formulation. And microgravity has shown some very drastic and profound beneficial effects for some drugs in that environment. The particular case here of Merck, they're looking at Keytruda, a therapeutic monoclonal antibody. As I mentioned, Lucy Lowe and our partners at the National Institutes of Health in both the National Center for Advancing Translational Sciences, that's NCATS, and the National Institute for Biological Imaging and Bioengineering, that's NIBIB, have sponsored 9 separate investigations to look at tissue chips technology. As Lucy mentioned yesterday, the tissue chips program is much larger than simply the tissue chips and space program. But this particular program and its focus on space is having very beneficial effects that permeate beyond the use of these chips simply in the space environment, but are actually informing the design and engineering and assembly of other chips that will enable them to be higher throughput and should speed their acceleration to clinical approval by FDA. I mentioned 3D bioprinting. So TechShot, who has a booth out in the audience that I hope you, out in the auditorium that I hope you've had an opportunity to visit, has been operating for the past 6 months on orbit, a biofabrication facility, which has already successfully printed cardiac tissue in the microgravity environment. They're currently completing checkout and see this to be a commercially viable platform for use by anyone in a little over a year. There is also a Russian solution to bioprinting in the microgravity environment that offers a different approach based on the suspension of organoids inside of a magnetic field on board the International Space Station. And another implementation partner, Made in Space, who has pioneered commercial facilities for 3D additive manufacturing, is seeking to move their capabilities also into the biological realm. So I hope you see that the business case is sound for low Earth orbit, and we at the ISS National Lab look forward to seeing it grow significantly in the next couple of years. Thank you.
Thank you, Mike, and it was a great presentation on showing how we're beginning to expand utilization of the International Space Station and beyond and low Earth orbit. Next, I'd like to introduce Tommy Sanford of Commercial Space Flight Federation. Tommy.
Thank you. I'm Tommy Sanford. I'm the Executive Director with the Commercial Spaceflight Federation. The Commercial Spaceflight Federation is the leading trade association for the commercial space industry, with more than 85 member companies, universities, and research institutions across the United States. Doug has covered how NASA has undertaken a number of initiatives to further stimulate the commercial LEO ecosystem, and Doug has discussed how the ISS National Lab is engaging new customers and expanding the ecosystem. I don't have any cool NASA initiatives or sweet access to the ISS National Lab. I just have policies, regulations, and laws, which I could nerd out about all morning, but I don't want to bore you with that this morning. This isn't Saturday Detention, or at least I hope it's not. Just bad dad jokes. So instead, I thought I'd take a different approach and take a few minutes to provide some historical context and an analog to the developing space economy. But then quickly turn it over to you all for Q&A, which I find to be the most interesting and fun part of these kind of things. So commerce consists of the physical movement of people and goods, and it only flows as smoothly as transportation technology, infrastructure, and operations will allow. In 1492, Columbus crossed the Atlantic in 35 days. 3 centuries later, passage from Europe to America took just as long. During the early 19th century, Atlantic voyages still sailed aboard wooden vessels powered by the natural energies of humans and nature, muscle and wind. But starting in the early 19th century, there was a sea change in transportation, delivered by revolutionary changes in transportation technology, the steam engine, and transportation operations, the packet line. Between 1820 and 1860, the introduction of steamboats, canals, turnpikes, and railroads shortened travel times and dramatically lowered shipping costs. Overlaying the transportation technology revolution was the transportation operations revolution, the formation of the first packet line, a regularly scheduled service as opposed to the old custom of ships sailing when they were full, a major contribution to expanding commercial activity. At the time, a ship owner might advertise a ship's day of departure, but the captain would then wait until cargo and passengers had been loaded and wind, weather seemed favorable before weighing anchor. A passenger hoping to embark might have to hang out around the docks, spending money on food and lodging and wasting time for a week or more. Then someone dealing in volatile markets for finished imports and raw exports wanted faster, more reliable service. They conceived the notion of a transatlantic ship line, several vessels under coordinated private management, sailing on known dates between established ports and locked into an unchanged departure schedule for the foreseeable future. This dramatically increased the economic activity, especially with use by small businesses. I would argue that both are occurring now in commercial space, both suborbital and orbital launch, reusability, and regular flight operations, which is underpinning the commercial growth in the microgravity research and development and manufacturing economy. Advancing launch technology like reusability to lower the cost of access is important, but also important is the regular and reliable access. This is not a new economic concept, it's 2 centuries old, but it's a new concept for commercial space operations, and it's a critical piece of creating new economic ecosystems on the frontiers of space. This is just one of several terrestrial analogs I believe is helpful in understanding the development of the space economy. There are several others, like the Blockbuster versus Netflix story, which I love, but I'll stop there, and if you're still awake, happy to take your questions, unless they're tough questions. Then I'll defer to Doug and Mike.
Thank you, Tommy. It was really interesting, because as we've seen in the past, how areas where government or so has started, began things such as aerospace and air flight, and that slowly moved into areas to eventually become commercial and what we now have as a large industry. And I think as we've seen from talks from Doug, where NASA is fostering the development of an industry and commercial sector in space, and the work that's being done by the international ISS National Labs and the work by Tommy to actually begin what has initially was a future to do work in the space to understand how life changes, to now begin to move it forward and evolve into an area where everyone from academic research through commercial and private industry can utilize this environment to really expand what we can and can't do. So what I'd like to do now is open up the floor to questions. And I noticed that there are students in the audience, so I encourage you to ask questions, because really this area of commercialization, utilization is really part of your future as well. And so I'd like to open up the floor to any questions, and please use the microphones. Does anyone have any questions?
Do you ever see a time when manufacturing might require additional nodes to the ISS? How would we do that?
Well, I think, is this on? That's one of the elements that's part of the business model for these commercial destinations that we're partnering with industry to develop. So they may be initially demonstrated by a commercial module that would be attached to the ISS, but in the longer term, I think they're developing their designs and concepts based on these potential emerging markets that could accommodate the sorts of manufacturing that we heard about of ZBLAN and other promising concepts. So that's I think an integral part of what industry is looking at as they shape the designs for these new commercial destinations.
Since I know each of you has thought about this a lot, I thought maybe you could take a couple of minutes each to talk about demand generation. And how do we move from NASA as the sole source of demand to a more broad base over time as we commercialize LEO?
Okay, I'll go first. Well, I think there are activities that we can do that are both near-term and longer-term benefits. In the near term, I think continuing to do the kind of things that National Lab is doing by providing access, basically, free transportation and accommodation at the station to industry to develop those markets. And that's showing some great promise, some of the examples that Mike gave, and has potential to do more. In the longer term, I think part of what we need to do is reach a much broader audience than the audience, or than the folks that are currently aware of or using microgravity as a means of conducting research. And I think this addressable market, if you will, is much larger than the community of folks that are currently accessing and using microgravity. And so in the long term, we've got to reach even broader, create more awareness out there in the research community, in academia, and in industry, of what the potential is for doing research in space and the benefits of doing things in microgravity. And the more people that are aware of this, the more opportunities for innovation. And I think one of the things that I'm interested in trying to pursue would be to create more of a standard educational approach where through certainly undergrad, but even in K through 12, students are introduced to the basic physical changes that happen when you remove gravity. And that's not part of the standard educational curriculum now, but I think the more folks that are aware of that, the more potential for innovation and creative new ideas. That's a longer term thing.
And I would pick up on that thread. We have seen significant increases in demand in partnership with NASA, in partnership with the commercial service providers and implementation partners, through the benefit of the excellent services offered by the launch service providers. We're maxed out. We've been able to utilize all of the available crew time, all of the available up mass and down mass for most increments that are available to us. And that's where NASA wanted us to be. It's where we wanted to be as a non-government organization with the mission to help create demand for that environment. And where we're at right now is we're seeing more and more commercial services come online that increase not only that throughput capability, but increase the fidelity of science that's returned from that environment. So we're in a transition point right now where I think there will be continuing momentum of some painful times where it still takes us a little bit longer to get stuff up to space and return data, return samples than we would like it. But it's better now than it's ever been in the history of space exploration. And it is only going to continue to get better through the efforts not only of NASA, through its commercial service activities, but also, and more importantly, through the efforts of organizations like the Commercial Spaceflight Federation and those companies that see space and low Earth orbit in particular, and cislunar as active new growth areas where there is significant potential for market growth.
So that's a great question, Erica. So I think it's several factors when it comes to building and developing more demand. I think the first is happening now with companies like Blue that are providing low cost, regular, reliable access to the microgravity environment. And so I think an increase in the number of platforms and their accessibility to users and current customers and future new customers is a very important aspect. After that, I think it's taking a long-term view of how we build demand. Often in the space community, we think of things, and for good reason, with Kennedy's moonshot that will go to the moon safely and return humans within the decade, that we often think about things within timeframes. But I don't find that as helpful when it comes to building demand for a new market. I think it's better to take a perspective of focusing on customer growth and retention and building out slowly, but always having that long-term focus that that's your goal. And then I also believe that it's important to illustrate and provide value to current and new customers. And I think that the ISS National Lab is doing a wonderful job at doing that, of reaching out to new customers and illustrating to them the potential value that doing R&D in the microgravity environment provides. And lastly is realizing that when we reach out to these new potential customers, that that we understand that we're one tool in the research and development toolbox for them, and that we're competing against those other tools to enable them to realize the goals for what their companies are trying to achieve. And while we all love space and think space is cool, that's not enough of a rationale for them to choose our R&D tool over others. And so we should always be mindful of that, because I think that that can help us be more competitive and win over future customers.
So a lot of the plans you've been talking about have been on a time scale of around 1 to 2 decades. Are there any groundwork put forth to accelerate that if things end up going quicker than you've expected? Heard a lot in the last couple weeks and months about SpaceX's Starship platform, which, while I think most of us expect their timelines to slip a little bit from what they are hoping to do, could be 1 or even 2 orders of magnitude drop in cost to orbit.
Yeah, and that's one of the biggest barriers, really, is the cost of access to space. So as cost continues to go down, there will be more opportunities, and I think you may begin to see the price elasticity come into effect in bringing in new markets and so on. And NASA's sort of in a midst of transition where from the beginning, NASA sort of owned and operated the vehicles that were used for exploration. And NASA's transitioning now to where we're looking to industry to own and operate the vehicles and purchase services as we're going forward. And I expect that transition will continue into the future.
Yeah, and to echo on a point that Tommy made, we're at a point now where we're going to see a sea change. There are going to be opportunities for private astronauts and sovereign astronauts to work in the space environment on projects that before were not possible simply because they couldn't be supported under the restrictions that NASA operated crew members under. We're seeing already people not only with designs, but starting to cut metal for new commercial services, new ports on board the International Space Station, for new free flyer activities that could operate their own laboratory services. So we're at a inflection point, for lack of a better term. I don't know I'm not smart enough or stupid enough to offer insight about how quickly that sea change is going to occur, but it's certainly happening. We're at the edge of lots of new opportunities, and part of it, is inspired by Cube Lab design, a new approach to engineering where you have modular-based design and there's less fear of failure. It's okay to blow things up occasionally. It's okay to have them fail and move on to it. There are many new services that are available both for ground-based investigation that directly inform spaceflight services, but a whole new litany of services that are available for low Earth orbit access. That's driving down cost. That's increasing the fidelity of design and engineering outcomes. And all of that, where it is beneficial, will translate into the space environment. And I think initially it will be low Earth orbit, and then it will go beyond that to cislunar and beyond. But certainly the timelines are getting better. The levels of funding that are coming into those activities is increasing, but it's a slow process. And no one in the venture capital community is going to be happy with their return on investment when those timelines are the way they are now. So you can hope to see continued commercial innovation from SpaceX, from Virgin Galactic, from Blue Origin, from SpaceX to continue to push the envelope. And that's going to benefit everyone, from fundamental investigators to the private astronauts to the tourists and the hotel operators who want to thrive in that environment.
So I agree that there's a lot of exciting things happening on the orbital front, from what SpaceX is doing to what Sierra Nevada Corporation is doing with the Dream Chaser to what Blue Origin is doing. But I think the thing that I'm most excited about in increasingly advancing what can happen in the microgravity environment is the new operations, newly coming on operations of commercial reusable suborbital flight providers like Blue's New Shepard and then Virgin's Spaceship Two. And I say that because those capabilities are allowing for greater access at a lower price point, even though it's for less time, but it allows you to buy down risk and allows people who may not want to go all the way to orbit, at least early on, to get their feet wet with just a couple minutes of activity. I think of it very much like, again, like the entertainment environment or economy, where Netflix really took off when you had numerous platforms to choose from, but especially when you had ones that were easily accessible like these. And I think it's similar to for the suborbital vehicles, that it really is going to advance a lot of things by people having access to that. For example, on Blue's last suborbital flight, they flew almost 40 payloads on one flight, which was just absolutely amazing, because that's twice as many, more than twice as many as the NASA's SMD suborbital rocket program flies in a year for tech development. So I really do think that that is the thing that I'm most excited about right now for advancing the microgravity economy and community.
Thank you for the talks. So as the ISS matures, is getting closer to the 2024 cutoff, and then most likely extended to the 2028, 2030 range, do you see parts of the ISS being, I guess, reused to free flyers? Or do you think it will all be deorbited?
That's certainly something that we've put out for both the path where there would be a commercial module attached to the ISS as well as the free flyers. So we're looking to industry to say, what fits with your needs for how you want to accommodate NASA's market and these other potential markets. So we're making those available to industry, and those will be part of the negotiations as we go forward, but certainly that's an option.
I'll wait for some other questions. I do have one. What do you see as some of the greatest challenges to really expanding in R&D research and industrialization in low Earth orbit? So for example, there may be groups who are sitting on the sideline right now waiting to see how things work out, or saying, hey, I've got these ideas, but I'm not sure whether I have the background information to really begin to expand and invest in the utilization of low Earth orbit. So I'd like to hear all of your thoughts on what you think are the greatest challenges, and possibly how the society might be able to help.
Yeah, and I think we've already touched on some of these, and you can think about them as barriers to entry. And I think the biggest one is still probably the transportation cost. And we're doing a lot of great work through National Lab, and you've heard a lot about those. But those are all subsidized activities where the transportation and the accommodation is provided at no cost. And NASA's spending over $3 billion a year currently for the operations of the ISS and the transportation to and from the ISS. And so there's growing demand that Mike talked about, and that's awesome. We want to continue to see that, but that's demand that they're not paying for the transportation or the accommodations. And so we've got to reduce the costs so that at some point in the future, industrial researchers and others will be willing to pay for that transportation cost. And we've got to increase the demand and make the value of doing activities and research in space apparent when they consider the business models. As Tommy said, there are other opportunities that they have to invest their dollars, and they won't do it in space just because it's cool. They have to do it because it makes a real business case. And since we're in Colorado, I have to use my ski area analogy that I used to talk about some of this. And there's a whole portfolio of things, and I agree with Tommy. I think the advent of the low-cost suborbital flights is going to really help spur things. But if you're, say, a ski area operator and you want to increase the number of folks coming to your ski area, and you've got the double black diamond runs and all the way down to green runs, and you want new people to come and learn to ski, you don't advertise to the new people, come ski our double black diamonds. And you can think about the ISS and research on the ISS as, you know, the double black diamond of space research. But there's also green runs like drop towers and parabolic flights, and maybe blue runs like suborbital flights. But you talk about those other activities that they can do that reduce both the real and perceived barriers to entry, and that's going to be important to bring these new entrants into the market. So in Colorado, I had to share my ski area analogy.
Yeah, so my list of things that don't work well right now. So I would begin with transportation costs that Doug highlighted. Logistics. We were very mindful in building the relationship with NIH to offer those selected investigators 2 flight opportunities in quick succession, because we understand that in order to do science, you have to iterate, you have to be able to fail and fly again. And that's been very important. So as we move forward in developing R&D opportunities for station, we have to be mindful that we have to work very hard to not only lower the cost and ease of access, but we need to work continually to shorten that timeline between flight opportunities for topic areas of investigation and for individual investigators. I think that's been a major factor delaying progress in research activities on board station. Funding. Everybody is starved for funding, so the more R&D funding from the public and private sector that we can see allocated to the space environment, then I think the more quickly we're going to see returns on investment going there. And last, and that this gets back to an earlier question, that the transition from an R&D based platform to a manufacturing platform, the International Space Station was not designed and cannot likely be operated as a large-scale manufacturing facility. But it is very effective as a research platform. It's very effective as a test kitchen where investigators, engineers, innovators can test concepts to inform them about manufacturing processes in the future. And the commercial sector, I think, is well positioned right now to take advantage of the data that's gained from use of the International Space Station and the National Laboratory to build the right facilities that are right-sized, that are operated with a concept of operations that enables manufacturing in the future. And that's very important.
So when it comes to the challenges, I've touched on them a little bit previously, but the first, I think, is really a mindset of taking a long-term view that what we're trying to do here is to build demand and a customer base rather than focusing on just utilization of a certain platform as well as just trying to cut costs to go and do other things. So I think it's a mindset shift and that we need to ensure that we're constantly focused on that we're growing our customer base and we're trying to have as many customers as possible. I think the second thing is that's a challenge is that sort of microgravity R&D is stovepiped within the federal government. And I think it would be very useful if there was a national microgravity strategy across government, led by a decadal teaming up with the various parts of the government and providing that strategy so that there can be a lot more synergy leveraged. And then the third is allowing for access to, not only allowing for, but leveraging the suite of platforms that allow customers to access the microgravity environment so that people can choose whatever it is that they want or need for whatever their use is. And maybe early on there are, just like as a customer and user of Netflix, there are a lot of shows that I don't like and that I don't watch, but there are quite a few that I'm hooked on. And it's those few that I get hooked on that makes me continue to be a customer there, and it becomes an integrated part of my life. And so I think it's very similar to the microgravity economy as well, as just allowing people to figure out what works for them. But that means allowing them to have access to these various platforms.
Sandra?
So that was a very nice lead into the question that I have. You have described how the commercial LEO economy can benefit this community by presumably creating a proliferation of research platforms and opportunities. So I want to turn that around and ask, of the various barriers that you see to achieving this future, what can this community do? What do you see this community doing to help you overcome those barriers?
Well, that's a good question. And I think to achieve the objectives that, that we see, you know, we need to have some commercial application to build these commercial activities. And so whether they be commercial companies doing research that can help inform things that they're doing on the ground or develop new markets that would actually be things produced in space and so on. You know, a range of things where, you know, the applied research can help identify what the path is to, you know, where companies or government agencies that are interested in doing research see the value in it, not just because it's cool and in space, but because given all the other, you know, options that they have for doing the research, you know, it's worth the added cost of doing things in space relative to, you know, doing things on the ground. So I think making it apparent that the value of doing things in space is worth it.
Hi. Oh, did you have a comment?
I was just going to say one quick thing.
Sure.
So a couple of words I wrote down. So collaborate, publish, innovate. I mean, the more, you know, the real power of this community is in the intellectual power of seeing value in understanding what the absence of gravity, what exposure to low Earth environment does for your science. So the more frequently you publish, the more active your participation in forums such as this informs the entire science community about what there is out there in addition to the exploration goals stated by the agency. So continue to do what you're doing and do more of it. And then where you are frustrated by lack of access, make those known through this society, through federations, through others, because we all, I think, as scientists, as researchers, as engineers, learn better together than separately. So the more we can identify common frustrations in doing that, the better off we're all going to be in the end.
Yeah, I would just foot stomp that last point. I think a really important thing that this group can continue to do and do more of in the future is to communicate to programs that you're a part of, that you want to be able to access these various platforms, and to ensure that the way the program is run is in a way that's a fair and open playing field, rather than being weighed towards certain capabilities versus others. And then also as a community, being willing to take on more risk. I know it's, you know, it makes a lot of sense that the scientific community is, you know, conservative. You know, that's a fundamentally good thing, but I also think it's important to take opportunities to take a little more risk and to fly on new platforms that you may not be comfortable with because you haven't done it yet, or that you don't think that their capabilities is quite the same as what you're traditionally used to. But I think you'll find out that taking that risk, there are a lot of other benefits that you hadn't thought about yet. And so I think engaging with those newer platforms that are coming online, I think would be very helpful for the community, because I think the community would be quite surprised about some of the benefits that are there. And I say that out of experience. I work with a part of the CSF is a suborbital applications researchers group, and a brilliant group of scientists and researchers from across the country. And they are really excited about the commercial reusable suborbital platforms that are coming online for that very reason. So I think that, you know, the rest of the community taking that perspective, I think would be helpful.
I have a kind of a quick and practical question for you, Mike. So going back to the ski slope analogy, there are these other platforms, simpler platforms, and I'm wondering of your your current customer base that has the most direct, that you see as having the most direct line as being commercially viable, whether those projects, I think you mentioned the fiber optic cable was one example. Are the current capabilities of other suborbital platforms comparable to the ISS? Can those be used for your customers or not?
Short answer is yes. So yeah, I had not heard Doug's ski slope analogy before, and just full confession, I'm a big fan of bunny slopes, and that's about as complicated as I'm going to get. No, but there certainly is a very important role for lower cost, much easier to access platforms to be available. And those inform not only those fundamental investigations, but those more transformative clinical translational applications in the end. So if our goal, part of our mission at ISS National Lab is to identify areas where industrialization has a reasonable chance of success, we have to have a continuity of access to those platforms. So I would say that there are certainly cases where there's not a good match between capabilities that exist on suborbital platforms, and there are other examples where we see them very well. We don't have a strong track record within the ISS National Lab of investigators who've done their progression through ground-based investigation to suborbital to orbital. And I think part of that was confusion about the degree of access that the commercial sector had to suborbital platforms. And I think that's going away now, so that they're now aware of what those capabilities are. And we've seen folks who've expressed interest in taking advantage of that as they formulate, they parse down the bad ideas and arrive at the good ideas and the way to do them actually in the space environment.
I'm wondering if that might be a gap for NASA, that is providing the resources and the opportunities for the ground-based and less expensive options to those who see in their sight line going into space. So that doesn't seem to me a very well integrated, on our part at NASA, a very well integrated process. So resources go into supporting research on the ISS, and yet it would be, I think it would be wonderful to take those customers and identify what ground-based or other suborbital platforms could be used to both set them up for successful spaceflight, but also, as you say, to provide other opportunities for commercialization and industrialization of the processes that that prove to be successful.
Yeah, there certainly are opportunities for improvement, and SLIPSRA uses the range of platforms for a lot of their research. We have the Flight Opportunities Program at NASA that takes advantage of those for a lot of technology demonstrations and things like that. But I think, and we've talked about this, and we want to make it as easy as possible for new entrants to see what the opportunities are and see what would be the best approach for them to get into it and make it easy for them to have access to those different platforms. So
Yeah,
it's really reducing some of those barriers to entry by making it easier for them to navigate all the options out there.
Yeah, and I just, for my 2 cents, I think it would be great to provide that as an opportunity to the commercial customers that find their way to the national lab.
We're with you.
So I'm just wondering, what's your guys' advice for young people and high schoolers and how to get a head start in the microgravity economy that's going to develop in the recent future or in the near future?
Well, probably for you all who are displaying some of your concepts here, continuing doing what you're doing, I think you're definitely the exception rather than the rule, though, in terms of knowledge of the opportunities, and share it with your classmates and your colleagues to get more people interested to come in. But awareness of all these opportunities, and there are going to be a lot more flight opportunities coming up, so pursue those and be part of the expanded customer base.
So this may sound a little crazy, but that's not the first time anybody's ever told me that. But I think there's a really exciting opportunity. Actually, I think that utilizing the microgravity environment for R&D across broad industries, especially non-space terrestrial companies, is really going to take off and be an important part of the economy in the 21st century. I look at the microgravity community here as sort of, again, this is one of my favorite analogs, but sort of like the writers and producers and actors from Hollywood that create content, and they got hired by Netflix and other streaming companies to write content because that's a specialty that they have. You all have a specialty in doing research in the microgravity environment. And I don't think that, personally, at least early on, I don't think companies, whether it's pharma companies or whatever, are going to try and recreate that capability themselves. So I think there's an opportunity for you guys to be the content writers of teaming up with these industries and helping them create content, microgravity content and R&D for their specific industry. And so I think there's a real opportunity there to be, those writers that go and write those shows for them. And I think that's a really exciting opportunity, and I think a wonderful chance.
Yeah, I would just say quickly, so you're here, that's a good job. So being there, I think, is very important. So where you have interest in seeking careers in space-based activities, continue to pursue those. Don't take no for an answer. Be persistent. Everybody out there is busy, and sometimes they don't give you the attention you deserve. But don't take that as a lack of interest and value in what you're doing. Keep at them. And I would say, just as importantly, don't be afraid to put ideas out there, because very often ideas come out and they're not quite as good as they could be. Sometimes they're bad ideas, but you still have to work your way through those. And I think that's nowhere more applicable than in the space environment. And we are at a unique time, I think, in our history of space exploration, where you can take your idea to an actual experiment in that space environment much easier than we could at any time in the past. So take advantage of that.
I think we have time for one more question.
So industry normally brings along with it a lot of waste production, and I think orbital debris is a big example of that. So in this new microgravity market, whose job is it to ensure that our LEO environment is used responsibly, and who regulates all of that?
Well, I think there's a self-interest in all the participants to reduce that. There's a lot of effort on space traffic management and orbital debris control, not just in the U.S., but with governments around the world, and a real focus for the UN on those things as well. It's been sort of self-regulating, and I think there's been standards adopted, and we'll see that improving. I know that's been a focus of things from the National Space Council as well. So I'm not going to predict what's going to happen, but I think it's in everybody's common interest to address it. So we want to see and encourage good behavior, and whether that has specific regulations or it's sort of just self done with the community, we'll see.
So I agree with Doug. I'll just make one point that the biggest creator of space debris is governments, whether it's ASAT test or actually a lot of people don't know this, that the biggest rule breaker of the 25-year deorbiting rule for satellites is actually governments. So governments following their own best practices and good practices that they like to see others follow, ensuring that they follow those themselves rather than get waivers or ignore them, I think would be very useful.
And it's a shared responsibility. Obviously, what we don't want to have is a repeat of our current experience with plastics in the environment. We've been manufacturing plastics for very good use and wide consumer appeal for many years. And lo and behold, they get in places all over our Earth. So the same lessons should not be repeated in the space environment. So we all take that responsibility. I'm reminded of David Newman's talk to kick this conference off, where she talked about the importance not only of science, technology, engineering, and math, but also art and design. So we need to think about, in thinking about manufacturing in the space environment, putting new satellites up there, that we are responsible for them. The manufacturers and the users of them are responsible from cradle to grave to cradle again. So that needs to be part of the design criteria at the beginning and not rely upon our ability to clean up the mess afterwards.
Well, I would like to thank, again, our speakers and panelists, Doug Comstock, Michael Roberts, and Tommy Sanford, for this very informative session on the economy, commercialization, and industrialization of space. Thank you so much for your time. Thank you.